All right, so today we are introducing the third project, but with that, I did want to talk about pipelines and grid search, which is actually a topic 32 thing, but I do think it'll make going through the rest of the stuff. And as you're getting started to like, as you're starting work on your projects, it'll help to streamline things a lot more and sort of uncover, the joys of scikit-learn. So want to go over two main things that are a big part of scikit-learn: grid search, which is for hyperparameter tuning, as well as pipelines. And pipelines is kind of what I was talking about, where you can sort of include your scalar with your model, and we'll get to that in a little bit. So to start, here's a new data set, no more miles per gallon, and this is what our data set looks like. It is on banknote authentication. I personally still don't know what that means, but there are 4 variables, 2 classes. And so we're going to use this data set just to see how we can employ grid search as well as pipelines. Cool. Imagine that all of this data is clean. Of course, you would have done some EDA. We're going to do a train test split to start. So let me pull up the documentation for grid search. Now, grid search is the tool used for hyperparameter tuning. The models that we've talked about so far don't have too many hyperparameters to tune. For example, k-nearest neighbors, you only have n neighbors as a parameter. Our naive Bayes, that one only has that smoothing alpha. Logistic regression has a bunch of hyperparameters as well, but next week's models, each of the models are going to have at least 4 parameters to tune. So this is going to come in handy when you get to that, and good to start incorporating it in your work from today. So I have the documentation up. We'll go through that in a little bit. So what grid search allows you to do is search through hyperparameters. And the way it does that, and I'll backtrack to explain the important parameters and attributes, but what it does is allows you to automatically test different values for parameters. So for example, for our k-nearest neighbors, if you remember, n neighbors is a parameter and weights is also a parameter, whether you consider each neighbor equally, or do you consider them based on how far away they are from your test data point. So out of curiosity, I want to see, what these combinations of parameters, how they work together, and which combination would be the best combination to use. So how you do this is you set up a dictionary of the parameters that you want to search through. Now, this is something that you can just define arbitrarily to start. If you're doing a large scale project, maybe for n neighbors, you want to search 1 through 40 and then start narrowing down. But do take note that the number of parameters that you're getting it to search through is the number of models that your grid search is going to train and test. So in this case, I have 5 n neighbors that I'm testing and 2 values for weights that I'm testing. So in total, I'm actually going to test 10 different models, because 5 times 2. Within grid search CV, the CV stands for cross-validation. So cross-validation is also being done for you if you do grid search. And by default, it does a 5-fold cross-validation, I think. Let me just double check real quick. CV, default none, default is 5-fold cross-validation. So with this setup, it's actually training and testing my model 10 times 5 times 50 times. And what it does is it fits your X-train and Y-train to all combinations of parameters, and it can give you the best ones. So let's run this grid search real quick. And this is a small data set, so it won't take that long, but do note that if you're searching a lot of parameters and it's a big data set, this cell might take even hours to run. So be very mindful of that. So what we did here, and I'll talk about verbose in a little bit, but you see here that we're fitting 5 folds for each of 10 candidates, because we have 10 different model candidates, totaling 50 fits. So just like that, we fit and tested 50 models. And then here we have our grid search output. Now, here we can go back to important parameters. So important parameters to note, scoring is a very important one, because depending on your business case, depending on your model, you might want to use different metrics. By default, most classification models, their default metric is accuracy. However, what if you have a business case that you want to focus on recall, because you want to you want to reduce the number of false negatives, I think. Yeah, if you want to reduce the number of false negatives, you might want to focus on recall. So if you want to focus on recall, you just have to change this parameter to say recall, and that'll work. You can also use grid search for regression. So if you go back to regression and you want to test different like lasso, ridge or lasso values of alpha, you can also choose to score, okay, do I want to do an RMSE scoring or do I want to do an R squared scoring? Depending on what's more important to your business case, you might choose different scoring, or you can do both. Next, you can also edit CV, the number of cross-validation by default is 5, and I think 5 is good enough. And also verbose, which controls how much information is output. A lot of libraries have this verbose parameter, but I don't think I've mentioned it before. Here you can see I put verbose equal to 1, and verbose equals to 1 prints this output. See what happens when I change verbose to 2? It'll actually tell me, give me like a progress report of what's being fit and trained. So this might be helpful if you plan on, testing maybe like hundreds of different models and like maybe leaving it for a few hours to run. You can come back and see what's being output. I think verbose equal to 3 gives you the score as well. So verbose equals to 3, you can see that the score is always hovering around 1. This is a pretty small data set, k nearest neighbors, 2 classes, scores around 1. If I change the scoring to recall, like I mentioned before, you might get different results too. Oh, it seems like it's all fun here as well. All right, so let's take it back to accuracy. Any questions about the setup of this? Set it to not 90, but 0.
If you're using it on like lasso or ridge, would you have to put in R squared, or does the default accuracy go for R squared?
Good question. So the default scoring is the default scoring for whatever model. And how you find that is, let's say I'm looking at scikit-learn ridge. Okay, so for ridge, you just have to look, no, this is grid search. Where did ridge go? Ridge. Classifier, there we go. Oops, not classifier. Linear model here. So the default scoring is whatever dot score is. So every model I think on scikit-learn has a dot score. So the default dot score for ridge regression is R squared. So by default, I think almost all, I want to say even linear regression too. Regression, scikit-learn. I want to say the default is also R squared. R squared, wait, did I go past it? Or yeah, I think it is R squared. There we go. R squared. And then if you want, I believe in scikit-learn it's actually not root mean squared error, but it's negative mean squared error. So yeah, you would have to tell it, but that's how you find out what the default scoring is. And for any, you're welcome. For any classifier, typically the score gives you accuracy, so mean accuracy. Awesome. So that's how you fit a grid search. You can also do dot predict, and I'll show you that in a little bit. But important attributes. So after you fit the model, you can get some data out of it. So first, what you can get is cross-validation results, which is really nice. So cross-validation results basically shows you for all 10 versions of the models, what was the score breakdown. They give you the fit time, which is nice. And the mean and standard deviation, because we did 5 folds, is the mean and standard deviation of the 5 cross validations. And you can see the different combination of parameters. So if I open this up, you can see this is 1 neighbor, 2 neighbor, 3, 4, 5, what weights it uses and what the test scores are. So here you can see our test scores, standard deviation of test score, and it ranks it as well. So it seems like for this case, because it was a very small data set, these are all ranked to be 1. So that means either n neighbors 4 or 5. And then I guess in this case, you can make a call of whether you want to use uniform distance or distance space weighting. But yeah, so here you can see your cross-validation results. Other things you can get the best parameters and the best estimator. So here straight up, if you just go through your search, and by the way, this search, it is the grid search object that you instantiated. You can find your best parameters, which will tell you the n neighbors is 4, the weights will be uniform. And then you can also get your predictions, and right out of that, you can do your metrics. And automatically, it will use the best model. So automatically, it refits with your best model. So here, if I'm just doing knn search.predict on my X test, I can actually get my confusion matrix and classification report all the same. So this is a really quick automated way to search through different combinations of parameters instead of instantiating a new model every time. Questions about grid search? Awesome. In a little bit, I'll talk about expectations of how much I expect you all to use grid search in your projects. Okay, so aside from grid search, another really powerful tool is pipelines. So pipelines is another thing that allows you to works as a model object. And we're going to use an example of using a scalar and k-nearest neighbors classifier. So the steps to create a pipeline is you first have to instantiate your pipeline with its components. So in this pipeline, I want to have a standard scalar and a k-nearest neighbors model. So if I instantiate this as my pipeline, when I call .fit, it's actually running my training data through both the standard scalar and k-nearest neighbors classifier. And it's pretty much doing a fit transform here, and it's doing a .fit here. It also knows that when you do a .predict, it will know that for here, you're only going to do a transform, and you'll know here you're going to do a predict. So it's pretty neat. It's like you don't have to have separate scalar objects being defined if you know that you want to scale your data. And so that's what I was saying, when you're creating your function, you might not have to have like a true false for scaling because you can just feed in your pipeline as your entire model. So in this example, what I'm doing here, I just fit my X train and Y train to a standard scalar k-nearest neighbors classifier pipeline. And I got my predictions. Again, the .predict will automatically do the transform for you and also run it through your model. And then same thing, I can get my confusion matrix as well as my classification report. So pipelines, another very, very useful tool to really streamline your modeling process. Questions about pipelines?
Does pipeline work on logistic regression?
Yes,
No.
A pipeline will work with any scikit-learn model. So even if you want to do scalar for your regression models, you can do that as well. Other things you can add into your pipeline. I know I haven't talked about SMOTE yet, but I think SMOTE is talked about in like topic 25 or 26. It's basically what you do when you have imbalanced data. You can actually add your SMOTE into your pipeline as well. Other things you can add your one-hot encoding. If you're using the scikit-learn version of Get Dummies, it's one-hot encoding. That can be added to your pipeline. So yeah, you can have as many steps as you want. The way that you define it, as you can see here, is a list of tuples for your steps. So here is like your scikit-learn object, and the first element has to be a name, and you can name it whatever you want. And in a little bit, I'll show you why these names are important. But pretty much you instantiate it as a list of tuples and with a name and a scikit-learn object.
Hi, quick question. So if you're doing the Get Dummies as part of the pipeline,
yeah,
does that mean that you need to run the pipeline like after you do the train test split?
So if you're doing pd.getDummies, which is different from scikit-learn's one-hot encoding. I mean, the results are the same, but they're two different libraries that work slightly differently. If you're doing pd.getDummies, I would say usually for dummy variables, unless you have a lot of them, it's not so serious for data leakage. So pd.getDummies is something that you can do prior to train test
Before,
split.
right? But if you're doing it in the pipeline, then like this, the scalar you can't do before you do the split, right?
Yes, correct. So with one-hot encoding, you can also do the same. If you're doing one-hot encoding and you have one-hot encoding as a step in your pipeline, that's actually the safest way to prevent any data leakage. So what'll happen is, let's say you have a categorical variable with 10 different categories. And when you do your train test split, let's just say your train test split only has 8 out of 10 of the categories. Now, when you do your one-hot encoding, because you don't want to have data leakage at all, you're only going to recognize 8 out of 10 categories. And that's just the nature of train test split. And then what'll happen is for your test set, what happens to those other two categories, they just wouldn't even be accounted for.
Okay.
Mm-hmm.
Okay. Thank you.
You're welcome. Hopefully that made sense. Any other questions about this? I would say like playing around with both grid search and pipelines is something that you should be playing around with just to get used to, you know, the way that it works and the way that you would use it. Okay. For models and for any step in your pipeline, models and, you know, scikit-learn objects all have attributes. And if you have your objects within your pipeline, you can still access their attributes, but slightly different. So the way that you want to access your attributes, so for example, you want to find like the predict probability from your k-nearest neighbors model, it kind of works like a dictionary. So let's say I want to get an attribute from k-nearest neighbors, I will call on my pipeline, and it's called scaled pipeline 1. I will call on my scaled pipeline, go into k-nearest neighbors, and actually let me comment this first. So this is actually my classifier. And if I actually were to do scaled pipeline 1 and then look at my standard scalar, oops, there we go. My standard scaled pipeline 1, there we go. That's my scalar object as well. And any attributes that come from the scalar, I can get from there. But usually scalar, you don't need attributes. But yeah, so this is my classifier object. So therefore, if I want to get predict proba, I can grab it from there too. And so you can see for each test data point, it's the probability of being class 0, probability of being class 1. And here you can see a little bit more variation than what we've been seeing before. Cool. There's a lot of functionality for grid search and pipeline. So if you run into anything or if you're trying to get some information out of your model, we can talk about it or just let me know. Okay, now to level up even more, you can combine your grid search with pipelines, because what if you wanted to run a grid search, but you want to have, maybe you can tune, so not for standard scalar, but there are some other pre-processing steps that we'll hit in the future that also have parameters that you can tune. So you can combine your grid search with your pipeline by first instantiating your pipeline, and then instantiating your grid. But now in your grid, you have to give it this naming convention. So when we defined our grid earlier, the keys have to match the hyperparameter name for the model. So in this case, n neighbors weights. If I called it something else like k neighbors, it will not work because invalid parameter. So it has to be n neighbors. So similarly for pipelines, these all have to match. I know this is a random forest, which we're going to talk about on, I think, Wednesday next week. But random forest is a good example because there's a lot of parameters for random forest. So let's say you only want to tune these 3 parameters for your random forest. You have to give it this naming convention. You use whatever you named the object first, followed by double underscore, followed by your parameter name. So that's the naming convention of how it recognizes what's used for what. If I wanted to do something for standard scalar, I would do SS double underscore, whatever that is. But standard scalar, typically you don't tune anyways, but just for future use, know that. Okay, so if I want to combine my grid search with my pipeline, you instantiate these, and I run my grid search. And when I instantiate my grid search object, I feed it in my pipeline. Grid is the same. I could give it different scoring, different cross-validation, all the same. I know this one's going to take a little bit to run, but yeah, as this runs, any questions?
That naming convention, the max depth min sample split, is that in the documentation of grid search?
Yes. Well, the naming convention that has the double, yeah. So these ones come from the model. So this is regressor, random forest classifier. Okay. So random forest classifier, which is a model that we're going to talk about next week. So you can see here max depth, min sample split, min sample sleeve. So it has to follow this naming convention after the double underscore.
Whatever that is, double underscore, then that. Okay, got it.
That's right. It's also, you can also see them here, but I like to read this one because you can also see the defaults, and that might help you choose what parameters to start with. Cool. So that's done. And you can get your best parameters. And one thing that you can get out of random forest, which we'll talk about next week again, is feature importances. So you can sort of think of it as like their version of coefficients. So if you want to get that out of just the random forest, you go into grid search, go into your best estimator, grab your random forest, and then get your feature affordances, which is that. And I'll explain what those are later. And then similarly, you can get your confusion matrix. Cool. So grid search is talked about, I forget which topic it is, but it's lumped together with one of the models somewhere. I have to go back and check where it is, but you'll hit it at some point in Canvas. And pipelines is all the way in topic 32, the very last topic of the phase. So if you wanted to see more documentation or work through some examples of that, that's where you can find it. But highly recommend using it in your project. And I'll talk about, when I get to the project guidelines, I'll talk about how much I want to see model tuning and model testing. Cool. Any questions about any of these? Oh, this notebook, by the way, is already on your study group repo. I uploaded it a few hours ago. Awesome. Cool. Now let's get into these guidelines. So I linked the guidelines. I think I updated it on your homework already. I think I also put it in Slack earlier today. So these guidelines are here for you. So the goal of this project is to train, test, and evaluate classification models. What I think is very important about this is to just get used to the usage of scikit-learn, and also to some extent getting used to the process of automation, which is why I'm getting you all to write the function. So once y'all write that function that I asked y'all to write, please send it over to me. I'm happy to look at intermediate versions as well. This project will be very code light once you're done doing that function. First, some dates to note. Today we're talking about the project. I would say like this first week, you can probably work on some data cleaning and EDA. The data sets that are provided are fairly clean. And if you want to use your own data, feel free to source it on Kaggle. I'll talk about parameters for a data set that you should be looking out for. But most data sets for this kind of project should already be fairly clean. So I would say roughly spend a week while you're still working through material to do some cleaning and EDA. Our presentation is on the 13th. So we still have 2 weeks until the presentation. So we do have a little bit of time. Iterative modeling, I would say right before the presentation, and then get your other deliverables done. And then the 2 weeks after the 13th is your project re-review. All right, so other than chain testing and evaluating, your other goal is to derive information from a final model to support your business case and recommendations. Now that is something that we will talk about more during office hours after we get through all of the models that we have to get through. Okay, so before we get to here, let's talk about some data. Where the data for our last project was pretty much looking for to predict a continuous variable. For this project, we're looking to classify some target variable. Things to keep note, at least 10 columns of data before doing your dummy variables. And then I would say the bigger data set, the better, honestly, just for sake of results, but try to get on average 1,000 rows per class at least. So if you have a 5-class classification problem that you want to do, or you find a data set with a target variable with 5 unique classes, try to get at least 5,000 rows. It's for the sake of your results. So there's that. And if you're choosing to do your own data set or source your own data set, just send it over to me and let me approve it first before you start working. Otherwise, provided there are 4 different data sets for this project, I believe. So hold on, let me pull up. I should have pulled this up earlier, but there are 4 provided data sets for this project. Pull this up over here. Cool. I'll talk about the pros and cons of these. So the first one is a Chicago car crashes data set. It's basically a data set that logs every car accident, I think for like the last year. There's also 3 different tables here, which you can decide which ones you want to use. And in terms of target variable, you kind of have a little bit of freedom to decide what target variable you want to use. So I know that in this data, there is like a measure of how serious an accident is. And so I've had people try and predict how like they sort of like bin the seriousness and try and predict like whether it's like a minor or major accident. Other examples, you can also do something like, I think someone also has done once like the cost of damage in an accident. So feel free to explore. This data set has a lot of columns. So feel free to explore and pick a target variable that you would like to use. This next one is Terry traffic stops, which is a data set on stop and frisk data. The natural column that you'll try and predict is whether a person will get frisked or not. I will caution this data set does have demographic information. So when you're using this data set, and if anyone ends up using this data set, please let me know, because I do want to talk about the implications of having things like race or like nationality, gender in your models. And I will spend some office hour time talking about that as well as we get more into next week's models. But there are some implications. If anyone has ever like seen those, what's the word? Like documentaries or books about how models have a lot of bias, that's something that I do want to talk about at some point. And this data set is actually a good example for exploring that, how bias can be very prevalent in machine learning models based on your training data. So yeah, as you can see here, if you do elect to make use of race or gender data, please aware that this can make your project highly sensitive. Your discretion will be very important, as well as your transparency about how you use the data and the ethical issues surrounding it. So I will have a short conversation about ethical issues of, using this kind of potentially sensitive data. Cool, but a very interesting one as well. Next is the Seriatel customer churn data set. It's basically a data set about Seriatel, which is a telco, which I don't know if it's in Syria, I'm not sure myself, but basically it predicts customer churn, whether it's basically something like customer retention based on, details of their phone plan, details about how often they use customer services, how many minutes they use, so on and so forth. Finally, there's a Tanzanian water well data set, and this is predicting the status of water wells in Tanzania. So based on a bunch of different things like region, like weather, like what else? Last time it was, what's the word? Refurbish? I forget the word, but predicting the status of water wells in terms of how upkept they are. This data set, pros and cons. Pros, it is an active competition. I think they actually pushed the date back, so it's still active. I don't remember. I forget when was the last time I checked this. Downsides is it is just known to be hard to predict. I think the highest accuracy numbers are not close to like you don't get higher than the 90s, I think, for prediction. But, you always have to compare it to a baseline anyways, similar to last time. So yeah, it's a cool data set because it is an active competition. If you're in for a little bit of a challenge, that's a good one to use. Nice. So sourcing your own data, I talked about that before. Any questions about data for this project? If you're thinking about sourcing your own data, you can definitely still download these data sets to see what this kind of data does look like so that you have some sort of reference point as to what your data should be looking like. Cool. All right. Let's go back to these guidelines. So with this project, very similar to regression, and actually for supervised learning in general, when you're doing modeling, there are 2 main reasons why you're doing modeling. For the purpose of prediction, which is, predicting your continuous variable like you did last phase, or predicting category in this phase. Another good reason for doing modeling is for inference, which is something I talked about last time, the fact that you through your regression, you can make conclusions on the relationships between, different aspects of a house and their price. You can get very, very similar information out of classification models as well. I haven't talked about too much of that yet, but we will. So in thinking about your data, in thinking about your business case, know that that can be part of it as well. Think about what features lead to someone being stopped and frisked? What features lead to a water well being classified as, good condition, not good condition, in need of repair? Or what features lead to a customer being retained by a telco? So definitely consider that when you're formulating your business case. And again, as with the last couple projects, this can be an iterative process. As you're finding things, you can definitely adjust your business case because this is, a project. All right, so yeah, why is it important to classify what you're classifying? And possible pros and cons of misclassification. This is actually very important when you're thinking about your business case as well. So let's just say you want to predict customer churn, customer retention. Is it better to incorrectly predict that someone churns when they don't, or is it better to incorrectly predict that someone doesn't churn when they do? Depending on your business case, it does matter which direction you prefer over the other. And that will also help to figure out which metric for classification you want to do. Sometimes, especially when you have a more imbalanced data set, and I'll get more into this when we get to office hours, but when you have imbalanced data, it's typical to want to focus on the recall metric over accuracy. And we'll get into that more next week and beyond. But do think about, all right, if I have this 5 class problem, are there differences in getting some classifications correct over others? That is important to think about as you're going into the project. After all of that setup, typical data cleaning and EDA. So perhaps ask some questions about your data. Similar to last time, this sometimes can help your EDA process. But also, how do your features relate to your target variable? Now, if you want your EDA to be closely related to your modeling results, this is an approach that I highly recommend taking. So very similar as to how for regression, a lot of our EDA was looking at linearity, because linearity is one of the strongest contributors to a strong regression. For classification, you want to see how your features relate to your target, which is literally what we talked about with regression and linearity. So for example, if I want to predict whether a customer churns or not, for example, this telco data, maybe one of the features is the number of minutes that a person uses on local phone calls. One way to know straight off the bat whether a feature will be good or not in your model is just to see if there's a difference in the distributions of features across different classes. So what I mean by that, and let me just draw a janky histogram here for you all. So let's just say I'm looking at number of minutes for customers. And my classification, I want to see if a customer is retained or not. So number of minutes, let's just say that this red histogram represents number of minutes, the distribution of number of minutes for people who churned. And then another histogram, let's say this orange one, represents the people who didn't churn. So if these histograms look different, you are more likely to have a better classification result based on this feature or using this feature versus if the histograms overlap. So instead, let's say you had a different feature, and this is going to look really, really ugly. So let's just say you have a different feature. That was number of minutes. Let's just say this is number of international minutes. So this is local minutes, international minutes. And let's just say for the 2 different classes, let's just say this one is class 1, this is class 2. The histograms are very, very similar. Then it is less likely for this feature to be useful in making a classification. So as you're working in your EDA, looking at the distribution of your features in relation to your target is going to be probably the more value-added EDA that you can do. Cool. So overlaid histograms is a good one. If you want to get even more technical with it, and this is not necessary by any means, but you can also do t-tests or ANOVA tests to see whether the means are different across your different classes. That's something that you can do too. Any questions about EDA? All right. The next step naturally would be a little bit of feature engineering. Before train test split, do make sure that your data is in a format that can be fed into a model, basically all numerical, no null values, because null values will throw off your scikit-learn models. And again, remember to prevent data leakage. Don't do transformations that have to do with the distribution of data before chain test split. So if you're using pipelines, naturally, that is not something that you'll have to worry about. But if you choose not to use pipelines, which there are reasons not to, sometimes just so it's a little bit more, not the opposite of, is a bit more transparent what's being done to your data if you don't use a pipeline. So yeah. Next, do your chain test split and baseline model. So last time when we were doing our regression, the modeling projects, this one versus the last one, slightly different. Last project, we were only using linear regression and we were making changes to our data. For this project, our data is not going to change very much in our different model iterations. Rather, we're going to be testing different models. So your data for the most part is going to stay the same. Maybe sometimes you scale, sometimes you don't, depending on the model. But for the most part, your data will not change very much. You won't be doing like feature selection, so on and so forth. So for your baseline, there are multiple ways to define your baseline. Perhaps you run all your vanilla models and pick one. So a vanilla model is basically a model with all of its default hyperparameters. So for example, in this random forest, these will constitute a vanilla model. For k nearest neighbors, a vanilla model will be neighbors equals to 5, weights equals to uniform. So that's what a vanilla model is. That's an actual term that's used in industry as well. So perhaps you do that. Or this is something that I found out maybe about a year ago. Scikit-learn has a dummy classifier, which is by itself like not an actual machine learning classifier, but pretty neat. It works as a baseline. So it makes predictions using simple rules, and it is useful as a simple baseline to compare with other real classifiers. Do not use it for real problems. And the way that the dummy classifier works, there are a couple strategies that you can use, but I think that the default is prior. So prior basically means, let's just say that you have a data set with like a 60-40 binary split. So class 0, you have 60% of your data, class 1, you have 40% of your data. And prior just means that it's always going to predict class 0 because that constitutes 60% of your data. So just predicting the majority class all the time. I think so. Yeah, that maximizes class prior. Most frequent, I think, is actually, maybe I was talking about most frequent. I don't remember, but feel free to play around with, I would say just pick one to be your baseline model if you decide to use this as a baseline model. Also works the same way as any other scikit-learn model. It has its .fit, .predict, all of those. And you can also incorporate it into a pipeline if you really want to. So yeah, same methods. So up to you to define what your baseline is. All right, so here also could be a good place to determine what metrics you want to focus on optimizing. So earlier, when you're introducing your project, yes, you talk about the pros and cons of misclassification. Here is where you just determine what metrics you actually want to use. Of course, in your confusion matrix and in your classification report, you see all of that information, but what number you choose to focus on and optimize for, that's something that you can go into more detail around this stage of your project with your first model. Next in modeling, I do say at least 4, similar to what we did for the last project. And by at least 4, I mean 4 different models. By different models, I mean like try like k nearest neighbors, naive Bayes, decision trees, random forests. That's 4 models. If you do like, let's say k nearest neighbors and you adjust your k value 5 times, that's still 1 model in this definition, in my definition for this project. So try at least 4 different models. Again, I linked the model summary sheet, which is also linked on your homework. Reduce repetitive code by creating functions. Hopefully you all will have done this before you get into working on this part of the project, because this will really truly streamline your process. And then, yeah, at least fit vanilla models for 4 different models, but up to you how in depth you want to go before you narrow them down. So one approach to this project is you can use the function that you created and literally test all of the models that we're going to learn. I think this is a list. I think this is a comprehensive list of all the models that we're going to touch on in the next week. So we have all of these models to talk about next week. But yeah, you can fit all of them, see which ones have the best results when they're vanilla, and then maybe take like the top 1 or 2 to fine tune with grid search. So when we're talking about grid search and tuning hyperparameters, I don't need to see it for all of them. I mean, if it's part of your function, you can do that too, but I only need to see grid search for 1 to 2 models, maybe just the 1, depending on how close your initial results are. Things to consider here, class imbalance. Maybe you want to try out new features that make your predictions better, up to you. But for the most part, if you hit like just running a bunch of vanilla models and then tuning 1 or 2, that's good enough for this project. All right, now finally, in your final model, pick your final model out of all the ones from before and interpret your evaluation metrics. What does a recall of 80% mean? What does an accuracy of 90% mean? Up to you to find out based on your data set. And then depending on which final model you pick, you might be able to do feature level analysis. So for example, feature importances, that's what we kind of had a preview when we saw that random forest code from earlier. Coefficients and probabilities. For that, I will go more in depth next week and also during office hours. So if that doesn't make sense now, no worries. And perhaps an analysis of misclassified data. If it's a data set where it makes sense to look at that, do that. An optional part, which was also an optional part for last time, you can create a prediction function using scikit-learns.predict. You can use their pipeline, and all you have to do, again, is create an array of inputs that match the feature set that your final model was trained on. Perhaps check out Python's input function. So if you want to give raw inputs, if you want to, create a little function that takes in inputs through your function, check that out. And then the rest of this stuff is the same as what we did for the last 2 projects, recommendations and future work. Recommendations for this project should be quantitative. I'm going to talk more about what this means in the context of classification next weekend when we do our office hours, and also model driven. So your recommendations shouldn't only come from your EDA. And again, I'll talk about that next week as well. Also, what have you learned from this model? And you can also draw conclusions and recommendations from EDA. So some of it can come from EDA, but some of it can be model driven. Finally, appendix or archives, if you have that. All right, so that's a lot of information. Hopefully you guys have a better idea of what this project is going to look like. Because I know we're not even halfway through the phase yet. Are we? We're about halfway through the phase. And so, yeah, a lot of this stuff we haven't really gotten into a lot of the weeds of yet. So over the next week, hopefully this stuff becomes more and more clear. And when we go through the material that's coming up next week, I will talk a lot about it in context of your projects. Cool. And same as last time, there's more Q&A down here, just in case you're curious about what people are asking questions about. Cool. Any questions about the project at this point?
Is the pipeline supposed to be in the function, or can it be in the function, or should that be separate?
So the pipeline, you know how I said previously that the input of your function should be your model? Yeah. Now it can also be replaced with a pipeline. So a pipeline works like a model, if that makes sense. So if you have a function that takes in model, you can also, it should be able to take in your pipeline as well.
Okay. Got it.
Yeah, because on your pipeline, for example, let's take this as an example. Here. This one? No, that's grid search. Oh, okay. So this is my pipeline. You do your .fit and .predict on your pipeline. So if I put this as my model input into my function, it should work as well. And you can rest assured that it is doing the scaling for you.
Got it, thanks.
You're welcome. Any other questions? Cool. Again, like I would say the most value added thing that you can do now is start working on that function, because that will truly, truly streamline your project. I think I told a couple, I don't know if I told you all this yesterday, but I told a couple of you during our one-on-ones that like, I've seen people who like have written these functions before getting to the project. They can finish the project in like 2-3 days, just because all of the work is done already. And it's just, you know, copy paste your model, press shift enter like 10 times and then you're done. And it's really just interpretation. So yeah, excited to see that. All right, any other questions? Awesome. Well, this notebook is on the study group repo. The guidelines are already linked in your homeroom and on Slack. So if there are any questions, just feel free to Slack me, Slack the channel, throw them to the bottom of here. You all have edit access to this as well. So more questions, you can throw them in here. But during our office hours, I might talk about some of the things in the questions section too. Awesome. Well, if there's nothing else, I'm going to stop the recording here.